Hello everyone and welcome back. In the last video, we explored getters and setter functions, where we understood how to get or set the values of variables. In this video, we'll explore variables in much depth with some data types as well. So let's get started. First, let us make a contract called variables and then have a variable my bool which is of data type boolean. So let me tell you that bool by default in Solidity has value of false. So now we want to do is that we want to set it to true. So for that we'll be declaring a function. How do we do that is we just define function set bool, then we pass in what data type will be the parameter that would be helping us to set the value. So we say bool, then underscore my bool. The function is public, and finally we say that my bool, which was earlier false, is equals to underscore of my bool. So when we compile this and deploy this, we will actually get a function that is called setBool, where we can set the value of underscore myBool to be true. So once it's true, by default, as the function suggests, myBool would be equals to true as well. So let's just see how this whole thing is done. So let me just compile this that I've already done also. Then I'll be deploying it. So you can see it's deployed. And here, so let me see what was the original value of my bool. So it's false, right? Now let me set my bool to true. So let me say true and call set bool. That's the function we declared. And now when I call my bool, it is true. So indeed, we have actually changed the default value of a boolean data type parameter or variable, right? Next, let's see some unsigned integers. We all know that unsigned integers have vary from 8 bits to 256 bits. So we can say actually that uint8 is public and we name the variable as my uint8 and the value would be 2 to the power 8 minus 1, that actually makes 256, right? Then what we do is we create a myUint wraparound function. So what's the logic with uint8 is actually that if you add 1 to 256, it will actually go around and make itself 0. Unless if you're using any other language, if you add 1 to 256, it will give you an error. But in Solidity, it just uses a wraparound function so that when you add 1 to 256, that is the maximum range, it will become 0. And simultaneously, if you decrement 256, 0 from 256, it will become the largest number, right? So let's make that function that uses my uint wraparound. It's public, it's pure. So pure functions are basically that those functions actually work within a scope of a given function only. They cannot be used outside, right? And it returns a uint8. So what are we going to do is we're setting a new variable that is called my0uint and we are setting it to 0 and then we decrement it. So what I've told you just now is that if you decrement 0 from 256, it becomes the largest number, right? So let's return my 0uint. So this whole sol is already deployed. So let me just go ahead and click on that. So my uint8, right? So let's see the value. My uint8 is 255. Now I have this my 0uint that is equals to 0 initially, and this is under my wraparound function. So here's my wraparound function, and I'm gonna see that when I decrement something or 1 from 0, what happens to the result. So it's actually 255. That is what we said earlier. We said that if we decrement 0 from any number, it will actually give me the largest number, right? So let's now see an example of division. So what we do here is that we have a function called division example. It is again public and pure and returns a uint 8. And then we have two variables. One is 5 and one is 2. So what do you think happens when you divide 5 by 2? In Solidity, you don't get 2.5. Instead, let me just run this for you, and division example is here. You actually get 2. You don't get point values in Solidity, right? So enough talk about uint, divisions, and all different kinds of wraparound things. Let's just have a look at bytes. So bytes 1 is actually a function here. It can be byte 32, it can be byte 8, and simultaneously uint is not only uint 8. It can be uint 16, it can be uint 32, and whatsoever till the range continues, right? So you can actually vary the numbers and values of the variables based on the data type. So as we were on bytes, so bytes 1 is a public data type, and bytes 1 we have declared a variable having bytes 1 data type, and we have set it to 0 cross FF. That's the maximum value, right? So now when we compare it with 0 cross FFFF, that is 2 bytes. So let's see, we want to return if my bytes 1 is greater or less than my bytes 2. Logically, we know that my bytes 2 is greater than my bytes 1 because 2 bytes are always greater than 1 byte. Right, so let's just click on my bytes compare function, and where is it? Here it is. So let me just see what is my bytes 1 first. My bytes 1 is 0 cross FF. My byte compare, let me call it here. So it's true. So it's true that 1 byte is less than 2 bytes, right? In the next one, we can actually get the value for the length of each byte. So we have the length of, what's the length of 1 byte? It is 1, right? So let's see if our value gives, if our function gives the same value or not. So let me just get my bytes length, and it's 1 because it's just 1 byte. 0 cross FF is 1 byte, so the length would be 1, right? And what if we don't use 1 byte, instead we want to use byte 32? So there are 32 bytes. So what do you think, that 32 bytes are more than 1 byte? Of course, it's true. So let's see if the function compare 32 and 1 returns true or false. 1 byte is less than 32 byte. I think it should say true, and it's indeed true, right? So this is a small demo that demonstrates the use of bytes, byte 32, byte 2, byte 1, some division examples, how we wrap around text, wrap around the values in Solidity, and how we use the basic data type, that is the Boolean data type, in Solidity. There are more to explore, and you can explore the various variations available in uint, like uint 8, 16, 32. You can just give it a try and try for yourself what the values suits you the best, right? If you have any doubts, do send it in the comments, and or just hop into our official Twitter handle and we'll clear your queries there. Thank you so much for joining. Happy learning!